So this is the third and final part of general relativity. Now, if you watched my previous two videos, you'll know that we talked about space-time a lot. Now, this is just a comment, but space-time and most of general relativity is described by what Einstein calls field equations. We're not going to go into them here because, well, they're a bit too complicated. But just a note, if you want to understand general relativity in its full, true form, you're probably going to need a lot of them. Now, what this video is about, wormholes and singularities. Now, as we classified in the last video, a singularity is a point of infinite density and temperature, where our laws of current physics begin to break down. However, we still know a bit about them. For one, we know that a singularity led to the Big Bang. This has led to several theories which were founded on or built on the foundations of general relativity, that basically a black hole could indeed contain the singularity which led to the expansion of the universe. Or another possibility is, in this case, that a black hole contains, again, the singularity. I'm just drawing these singularities outside the black hole just for clarity's sake. That could actually lead to a wormhole, to a white hole. Now, I'll just explain what these two are. A wormhole is a bend in space-time. It's commonly referred to, the most common way to interpret it is that if you have a piece of paper, say you want to get from point A to point B. Now, as geometry tells you, the shortest distance between 2 points is a straight line. Now, you could go across the straight line here, but a much, much easier way to do so would be to bend these 2 points like so and poke a hole through. That means you can get from point A to point B instantaneously. Now, imagine this diagonal distance. Now, it's just a couple of centimeters, but imagine if it was millions of light years across. You wouldn't want to travel such a long distance. You'd probably want to bend space so that it creates a wormhole. This bending of space is the wormhole, as I said. However, there's a few key points that we have to remember. We can't bend wormholes just on our own. It's theorized that it needs something called negative matter, or exotic matter as it's called. It's not matter that has negative gravitational properties. We don't know what it is. That's the problem with scientists. They make up things and then they don't know what they are. But basically, this negative matter, exotic matter, green matter, whatever you want to call it, bends space-time so that a wormhole is created. The only thing is, if we take this literally, this amount of negative matter is extreme. Just to create a wormhole a football field wide, you'd probably need as much negative matter as the Earth has. That could mean destroying an entire Earth-sized object. And to create a wormhole, like in the movies, where there's millions of light years across, you'd need more than you need more matter than the whole universe has. So, negative matter is quite a problem when creating wormholes. Stephen Hawking, who continued on the ideas of relativity, stated that, well, you could actually create a wormhole very easily. There are things called quantum wormholes. I'll go into quantum mechanics in another lecture, but in these quantum wormholes, they just cover a couple nanometers, but you can scale them up, and then they can cross entire galaxies, the widths of entire galaxies. You can scale them up and pass through them. Another thing about wormholes, because they're distortions in space-time, you can travel across space and time. That means you can use wormholes as time machines. Another time machine method is to orbit around a singularity. In the same way, because a singularity is so incredibly massive, because, of course, it has an infinite density, that it warps space-time to such an extent that you can slingshot around it and pass through time, so to speak. In fact, this is related into a white hole. Now, it's important to know that both black holes and white holes are made of have singularities in the center. White holes are slightly different, though. While a black hole pulls everything towards it with gravity, white holes operate on anti-gravity, meaning that while you will never be able to escape from a black hole once you meet its event horizon, you'll never be able to meet a white hole's event horizon, because you'll be constantly pushed away from it. That means white holes, constantly emit things. So it's theorized that black holes are connected to white holes via wormholes. That an object passes through the black hole, gets destroyed or distributed by the singularity, because nothing can survive there, I assure you, just try it, and it passes straight through the wormhole and gets emitted equally violently through the white hole. That's the black hole, white hole, wormhole connection. So, I'll just summarize the entire theory of relativity as best as I can. The general theory of relativity is basically founded on the ideas of space-time. Space-time is this elastic fabric that stretches across the entire universe. Large and heavy objects like planets, asteroids, stars, black holes can make dents in space-time, and on the opposite sides there are hills in space-time. Things like black holes, wormholes, and white holes make incredible dents in space-time. Black holes make such huge dents that if you were to be at the event horizon of a black hole, you wouldn't be able to escape. And white holes are the opposite of black holes, so to speak. While black holes tend to draw everything towards them, white holes emit things. We don't know white holes exist, by the way. I'll just put that point. Most of the scientific community doesn't believe that they exist. And wormholes could be the connection between black holes and white holes. It's incredibly hard to make wormholes, and it's incredibly hard to travel across them. But if we would, we could have the possibility of time traveling, because singularities are so vast and dense, they can cause space-time, again, which is a combination of space and time, to warp so much that you can slingshot across it or pass through it to another time or another space. But time travel is very difficult, by the way. And so that is basically general relativity. So the main points you need to know: objects distort space-time. There are things called black holes and white holes and wormholes. Black holes draw everything close, white holes emit things, and you can pass through wormholes through a different time and space. Those are the main things you need to know about general relativity. Thank you.